Hi, my name is Jesus Alberto Redondo and I'm going to present an example using the Shanons development theorem. First, this is our function, is f is equal to g z inverted dot z inverted or z inverted x plus x inverted plus z inverted dot x inverted g or x inverted z. So first what we need to do is to put the function. The Shannon development says that we need to evaluate our function in 1 multiplied by an x and then add an or with an x inverted multiplied with the function evaluated in x equal to 0. So first we are going to see our first function are going to evaluate in 1. In here we have an x and we're going to put a 1. So all this is going to be a 0 inverted. Multiplied by this is going to be g 0 inverted. Then we're going to evaluate the next part. Also we are with x equal to 1. Here we have an x inverted, and x inverted. In here, like is an inverted, we're going to have 0 and 0. 0 plus 0 is equal to 0, and 0 multiplied by anything is going to be 0. So we are going to have a 0 and we don't put anything. Now we're going to the other part. We're going to evaluate in x equal to 0. So we're going to have g0 inverted or g or c. Now we reaccommodate and we have this function. Only this is going to for part x. Now we're going to do the same but with our variable j. So we put our function with the Shannon's development and we're going to evaluate but this function. This is going to be our new function. So we evaluate first with j equal to 1 and then with j equal to 0. In first part we have this. Then in our next part we have this. In this part we only have x inverted 0 because as we know we have a g here, a g here, and a here, and it's not inverted, so it's going to be 0, 0, and 0, and we only have this part. Now we reaccommodate, and then this is going to be our new function. This is for part j. Now we're going to do the same but with the variable z. So first we evaluate z with 1 and we have this result. Then we evaluate with z equal to 0 and we have this result. Then we reaccommodate and we have this. In this we can notice that we have this and this the same. So we need to remember that it's going to be the same and then we put only 1. Also this and these combinations are going to be the same, so we put only 1 instead of 2. Then we need to remember to reduce our function. We can use the theorem 6 to reduce this function, and we are going to apply in these two terms, and then from these two terms we are going to have this. Also in here we are going to apply our theorem 6 in these two terms, and we are going to have our final results with our function equal to x inverted z or j z inverted. Now we are going to apply our Shannon's development theorem but with a product of sums. We need to have this product of sums. So our function is going to change. Now we are going to have an x plus our function evaluated in 0 dot an x inverted or a function evaluated in 1, x equal to 1. So we start. First we're going to evaluate our x equal to 1. So this is going to be our result. Then we're going to evaluate our function in x equal to 1. This is the same as the last exercise where we have an x here, an x here, and an x here, but are inverted. So this is all this is going to be 0, and we only have c inverted. Also, this is our part only for x. We're going to do the same, but with our new function that is going to be this. Now with the variable j. So we start doing the same. Our j equal to 0, and we obtain the result x or z dot x inverted, and then or j equal to 1. So here, as we notice, we are going to have a result of 1 here. And we know that in a postulate, if we have a 1 in a combination, all this is going to be 1. So when we accommodate our function, we only add this part that is in here. Then this is our part only for j. We do the same for z. So we evaluate z equal to 0, and this is our result, and z equal to 1, and this is our result. We have the same case here. We have a 1 here, so all this is going to be 1. A difference at the 1, this 0, it's only going to be a 0. It doesn't matter. So we accommodate our function, and it's going to be this. And we need to remember that also using our theorem 6, we could use for this 2 and for this 2 to give us a result of this. Thank you.